Hello and welcome to our special Ask the Expert session on Mars. My name's Natalie and I work as a science communicator here with the Open University. I work alongside an amazing group of scientists and engineers, some of whom we've got here today as experts on the planet Mars. If you're watching on Zoom, then we can't see or hear you, but you'll be able to interact with us in the chat box at the bottom of the screen. So send in your questions whenever something about Mars springs to mind. But don't worry, it's only us that can see your questions. So if you make a mistake, then it's not a problem. You can always just send us another question. If you're watching on YouTube or at a later date when we aren't live, then I'm afraid you won't be able to interact with us. In just a week's time, the American Space Agency, NASA, will be landing their Perseverance rover on the surface of Mars. Percy, as we could call it for short, will be looking at whether Mars is habitable, which means it will be looking at whether it's possible that Mars hosted life in the past. That's a rather exciting prospect and one we'll investigate more today with our experts. But first, to get your brains in Mars gear, let's start with a question for you at home or at school. And if you're watching on Zoom, you can join in by selecting the option you think is correct. So I'm just going to put a question up on the screen. Here we go. Is Mars bigger or smaller than Earth? What do you think? If you think Mars is bigger than Earth, you can click the top one. Is Mars smaller than Earth? Then the middle one. But if you think Mars is about the same size as Earth, then click the bottom one. Let's have you a little time to think about that. Don't worry, no one else is going to know the answer you choose. It's anonymous, so just take a guess if you aren't sure. If you're a teacher in class, then perhaps you could take a show of hands to get the most popular answer. Give you a few more seconds to have a think. I'm going to end the polling in 5, 4, 3, 2, 1. Oh, got another one in there. Okay, so I can share the results with you. A lot of you, I'm going to say 67%, which is more than half of you, thought that Mars is smaller than Earth. So those of you that selected that option, you can give yourself a big pat on the back because that's correct. Mars is actually about half the size of our planet, but it's actually over 2 times larger than our moon. So if you were to look up in the night sky and switch the moon for Mars, it would look about double the size. That would be quite impressive. Now, it's important to think about the physical characteristics of the planets, things like their size, but also what they're made from. They could be made from rock, gas, or ice, or all of those things. And things like how far away they are from the sun, because all of these physical characteristics have played an important part in how they look today. Now, we're going to learn more about this as we go through today's session. So, do you have some questions you want to ask our scientists? You'll meet them in just a few minutes. I'm just going to stop sharing those results on the poll in case you can see those. You'll meet them in just a few minutes and you can put your questions in the chat box whenever throughout this whole session, but I'll be putting your questions to them in just a minute. So what I'm going to say now is let's meet our scientists, because I've been chatting for long enough and we've got all these lovely experts here with us today. So if I can ask Amy, Suzanne, Mario and James to turn their cameras on, then hopefully you will be able to see all of them. Have we got everyone? And we can give a big wave, and we're going to meet all of these people throughout the morning. But first of all, we're actually going to be talking to Amy. Before we hear from Amy, who's our first scientist, I'm going to put another question to you at home. And Amy's going to actually answer this question in her talk. So you've got to keep listening to get the answer. So let me see. Let me put the question up. Launch polling. There we go. What is the environment like on Mars today? So do you think it's hot and dry on Mars? Do you think it's cold and dry, like a cold desert? Or do you think it's hot and wet? Do you think Mars has water on its surface? So we've got lots of answers coming in. Brilliant work from everybody. We're about equal pegging at the moment for hot and dry and cold and dry, but we have a couple of people thinking hot and wet. So give you a couple more seconds to have a think about that. Okay, I think that's most of the answers in. I'm going to end the polling and I'll share the results with you all. So we can see that 58% of you, in fact, thought that Mars was hot and dry. 41% thought cold and dry, and just 4% thought hot and wet. So we will hear from Amy now, and she will be able to tell us which of those is correct. So let me close the poll. So Amy, welcome. Are you ready to go with your slides to tell people a little bit about what you do?
Yes. We'll share my screen. Can you see it all right?
That's fine. We can just make that full screen, so we've got it on slideshow.
Okay, so hello, my name is Amy. I'm going to give you a little bit of a background on Mars, why Mars is interesting, why do we want to send a rover there in the first place. So before I do that, I'll give you a little bit of a background on me and how I came to studying Mars. So while I was at primary school, I found out that I was dyslexic. So that meant that it was a little bit more difficult for me to learn to read and to write and to spell. But I really knew that I was really interested in the world around me, and I really liked asking questions. So when I went to secondary school, I picked as many science subjects as I possibly could, and I really enjoyed them. But I found chemistry a little bit difficult, so I had to work that bit harder to figure that out and to get to grips with it. After school then, some people might choose to go to university. So that's somewhere that you can do a course that's more specialised to your interests. So the first time around that I went, I didn't really like the university I was at. I didn't really like the course, so I dropped out. And I had to ask myself a lot of questions about, well, what do I really want to do? What kind of a place do I really want to be? But I did go back and I studied biology and chemistry in a smaller university. And that gave me the skills that I needed to go on to study Mars. So you might ask, first off, well, where is Mars? Where does it sit in the solar system? So you can see it here. It's the fourth planet from the sun. We have Mercury, Venus, Earth, and then Mars. So you can see from the picture that Earth is that little bit smaller, or Mars is that little bit smaller than Earth. Now the gap between Earth and Mars in the picture is a little bit deceiving because the nearest that Mars ever gets to Earth is actually 55 million kilometers. So that's a really, really big number. It's hard to get your head around, but that would be like running around the circumference of Earth 1,375 times. You can imagine how tired you would be if you had to do that. So that's why, while Perseverance is going to land on Mars next week, it was actually launched 6 months ago, back in July, to get there in time for its landing next week. So when these spacecraft get closer to Mars, what do they see? So most of you will know that Mars is red, and the reason for that is that it's covered in this iron-rich dust, similar to how when you have an iron gate and it rusts, when it mixes with the oxygen in the air and it turns red. It's a similar reason for the iron-rich dust on Mars. Underneath that then, Mars has predominantly basalt rocks. So these are volcanic rocks like the ones you would see on volcanic islands like Lanzarote or Hawaii. Some interesting surface features that we see on Mars. So over here we have Olympus Mons, and it's a giant volcano that no longer is active. So it looks quite flat here, but it's actually double the size of Mount Everest. So you can imagine it's so hard for people to climb to the top of Mount Everest. How hard would it be to climb to the top of Olympus Mons? You can also see this massive canyon system. So that's similar to the Grand Canyon in America, but it's much, much bigger. But the main reason that we're interested in Mars is this possibility that there was water in its past. So today, Mars is actually dry and cold. So a lot of you said that Mars was dry and hot, and that's a misconception because of its color. People often think that it's very hot, but it's actually very cold, and it's got a really thin atmosphere. However, millions of years ago, it's thought that Mars was wet and warm, and that's because it had a thicker atmosphere, and that thicker atmosphere would have acted like a blanket to keep it warm and allowed there to be liquid water on the surface. So many scientists that study Mars really want to know more about this water. How long was it there for, and how much water was there on the surface of Mars? You might still not be convinced. You might say, Amy, water doesn't sound that interesting. There's water everywhere on Earth. Why should I be interested in it? So while there's water everywhere on Earth, Earth is the only place in the solar system that we know that there is life. And it turns out that this water is really essential for life to exist on Earth. As well as that, we need nutrients, we need energy, along with all the other living things on Earth. So when we try to look at other places in the solar system or in the universe, we might want to ask, well, can we find places where there are liquid water? Can we find places where there might be some source of energy and nutrients? So when we look again at this Mars that we see millions of years ago, where we think there was this ocean covering the top of the planet, it turns out that this early Mars is very similar to what Earth looked like millions of years ago when life first emerged, and we saw microbes on the surface of Earth. So that raises the question, could there have been microbes on the surface of Earth, on the surface of Mars millions of years ago as well. One last thing you might be wondering, okay, we're talking about could there be microbes on Mars millions of years ago, but have people ever been there yet? And no, the answer is not yet. So we've seen many science fiction movies that look at the possibility of humans traveling to Mars. What would it be like for humans to be on Mars? So you can see the astronaut over here, and when they take a step on Earth, a lot of effort only gets them a little step, and when they take a step on Mars, they get to make a big jump. And that's because gravity on Mars is less than it is on Earth. And that means that you would effectively weigh less, and it'd be easier to take that big jump. And while that sounds fun, one thing that we need to consider if we were going to send humans to Mars is that this would actually have a really weird effect on the body, because we're so used to being on Earth, and that it might cause our bones and our muscles to weaken. So that would be something that we would need to consider. So maybe you can think about this as the other participants talk about the studies that they've done on Mars, and say, oh, what would it be like if I was to stand at the place where I'm seeing someone else show a picture of. So thanks, Natalie.
That's great. Thank you so much. That was a really good introduction for all that information about Mars. There's so much to take in, but I loved that actually we've learned that it's cold and dry. It's a cold desert on Mars, but actually the people that thought it was kind of wet weren't so wrong, because it seems like millions of years ago, it really could have been a really wet planet, which is really interesting. So if you have any questions for Amy, then please do send them in using the Q&A chat at the bottom, and we'll be able to ask her those when we've met all our scientists. Now, next, we're actually going to meet Mario. Mario, are you ready to go? Brilliant. If you want to share your screen, we'll hear a little bit more about astrobiology from Mario, which is a really fascinating subject, something that he's been researching for a while. There we go. You ready to go?
Yeah, can you hear me?
We've got a bit of background noise with you, Mario, but I think...
yeah, my fiance is talking on the phone at the same time because he's working from home as well. So
oh dear,
I'm sorry for that.
That's okay. We'll put up with him if he has to do some work. Okay, you take it away. Thank you.
Right. So as Natalie has said, my name is Mario. Just to talk a bit about myself, I came from Spain, from a very small village in the mountains. And by very small, I mean 150 people. I was always very curious about what was around me. So this is when I decided to go to university. And similarly to what happened to Amy, I also struggled a bit with some of the units. And actually one of them was microbiology, that I failed on my first chance. And then I retook it and passed. And nowadays I'm a microbiologist. So that you have a bit of a setback, that shouldn't stop you from trying to achieve your dreams. So nowadays I'm a postdoctoral research. So basically what I do is investigate how microbes and minerals interact and what kind of gases they produce and how this could happen on Mars should it have life. So what I do is analyzing what type of gases they're being produced by microbes in very extreme environments that I'm going to talk about. And if those gases appear on Mars, trying to identify whether microbes could have been producing them in the past. So before we start to talk about me, I work on something that we call analogues. Analogues are places that are similar on Earth to some of the planets. So for example, the one I work in are similar to Mars. So I'm going to now show you some pictures. You should have an option at the bottom of your screen to raise your hand. So I'm going to show you pictures, and I want you to raise your hand if you think that the picture that I am showing is from a place on Mars. Okay, so let's see the first one. This one, do you think is on Mars? If you think so, just raise your hand, and I'm going to give you like 10 seconds. Dun, 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 dun. So actually, this place is on Mars. I can't see the numbers, so I don't know how many have said that they are Mars, but if you have, well done you. Let's see the next one. Do you think that this is Mars? This is Earth? Remember, if you think that this is Mars, just raise your hand. I'm going to give you like 5 seconds. This is actually a desert in Namibia on Earth. And let's see the last one I'm going to show you. This one. If you think that it's Mars, remember, just raise your hand. If you think it's on Earth, don't do anything. This one, dun, 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 is actually on Mars. This on Gale crater that Susanna is going to talk about later. And actually, this links very nicely to what my research is about. So what do we think that analogues are? Well, analogues, as I said before, are places on Earth that are similar to places elsewhere in the universe, or in our case, elsewhere in the solar system. We define fidelity as how similar these places, these analogues, are going to be to the place that we want to investigate. So for example, if we want to investigate a place on Mars, it has to have similar temperatures, or the gases in the atmosphere around the place should be similar, or the chemistry of the environment should be similar to what we have on Mars. It's important to remember that there is no such a thing as a perfect analog, because if you think we are not on that planet, we are on Earth, and obviously that means that the conditions are going to be different. So we have to find places that are going to be as similar as possible, but always acknowledging that there's not going to be a perfect match. So some of the places that can be considered analogues on Earth are, for example, Rio Tinto in southern Spain, which is a very acidic, very iron-rich river. This is why it is so red. Glaciers in Iceland that are on top of basalt. And if you remember what Amy said before, the rocks that form Mars are basically basalts. And finally, we're going to have the Atacama Desert, which is a very dry place on America. I'm sure that Susanna is going to talk about it a bit afterwards. So on my research, as I said, I am trying to find microbes that produce certain gases. But what am I using as an analog? Well, if you remember, when Amy was talking, she said that Mars in the past had water. When you have water and you have rocks, the interaction between the water and the rock is going to yield to the dissolution of the rock. So basically part of the rock is going to change and it's going to leave the rock and go into the water. And if you remember from experiments that you could have done in the past, if you have salt in water and you have it in a glass and you let it to evaporate, what you're going to have at the end is that a bit of the salt is going to deposit at the top of the glass that had the water. And the same happened on Mars. So if the rock was dissolved by water, when Mars lost its atmosphere, the water disappeared, some of the salts appeared. So what happens is in the process of this evaporation, of all this water disappearing, the concentration of salts are going to increase. And we know in certain places like Gale crater, a huge amount of sulfates, which is one of these kind of salts, appear. So we were decided to find a place on Earth that is similar to this Gale crater as it was evaporating. And we found these lakes here that are in Canada, in Western Canada, that contain a huge amount of sulfate. And we think that it could be similar to what we had on Mars in the past. So my role as a researcher is going there and I get the gases. So this picture on the left is me sampling gases. So this box here, actually, what it makes is vacuum, and I have bags inside that allows me to suck the gases in. And then when I go back into the lab, I can analyze them. But also I took sediments and I took water and I tried to find what kind of microbes live there. And if those microbes that are there are producing the gases that I have on the bags that I am sampling. I think that that's all from me, and I'm going to give it back to Natalie.
Great, thank you so much. I love it. It's so fascinating that you can actually do Mars research, but on Earth, looking at all these environments that we think are very earthly, but actually they can be seen as sort of Martian in some ways, which is very, very cool. And it means you get to travel and do lots of exciting things with your research. You're not in a lab all of the time. Well,
not much traveling nowadays, sadly.
Sadly, but there will be one day again when all of this pandemic is over and we can go back to normal. No, that's fantastic. Thank you so much. So we're going to hear from Suzanne next, but before we actually get started, I'm going to ask another question to you at home. So if you're watching on Zoom, you can join in. The question I'm going to ask you today is, as of today, and this is when we're recording, which is the 11th of February, how many rovers are active on Mars? If you think it's, oh, I need to launch the polling. There we go. If you think it's just one rover that's active on Mars, then click that one. Are there 6 rovers that are active on Mars? Are there 11, or are there even 21 active rovers on Mars? So active being they're still doing their work, they haven't, their batteries haven't died, and then just sat there. So these are the ones that are actively doing science on the red planet. Give you a couple more seconds. We're getting lots of different answers coming in. I say the most popular at the moment is 6 rovers. Now, I'm not going to tell you the answer. I will end the polling in just a second and put up all your answers up here. And then Suzanne is going to be able to reveal which is the correct one. So I'll end it there. I'm going to share those results with you for a second. So we can see just over half of you thought that there were 6 active rovers. So we're going to hear from Suzanne now. I'll stop sharing those results. Hi, Suzanne, are you ready to go?
Hello. Now I try that thing about sharing my screen.
That looks good. Thank you. Take it away.
So I am going to reveal the answer to the question, and I'm talking to you about current missions to Mars, which are still active. And I'm afraid we only have 2 altogether, and one of them is a rover. But in good fashion of this session, I am saying a few things about me before I go. You see, Mario said I will be talking about the Atacama. This is me in the Atacama Desert here on Earth. It looks utterly like Mars, especially with this rover model in the background, which is a model of the upcoming ExoMars rover from ESA, but that's what James is going to talk about. So who am I? Well, I am German. You might hear my accent. And I finished school a long time ago. My career is much longer because simply I'm a bit older than everyone who spoke so far. And so I have this long list of things there. But all I want to say for today is, when I was your age, I wanted to be a journalist. I wanted to travel the world. I wanted to find out things and report them to a general public, write, be on TV. Well, it came a little different because I studied mineralogy. That's about the tiny crystals that you might see in a rock when you pick one up, say at the beach. And I still wanted to be a journalist while I studied. So I was a volunteer editor of a museum's journal, and I really was into that. But then I caught the Mars bug. When I got my PhD, I worked on Martian meteorites that are rocks that have been done all the journey from Mars to here all by themselves and fallen on Earth as a meteorite. And then I had my PhD and I started my career as a scientist. I was in Germany, I was in the US, and in 2009 I came to the Open University. And that's enough about me because you are curious about Mars. So this is one of 2 active missions on Mars, but you don't see wheels on this image because it's a lander. This is inside. It landed on Mars and it is sitting there to see whether Mars has earthquakes. So every planet can shake internally. And if we study this shaking, we can learn about its interior. For example, about its where the crust ends and the mantle starts and the core starts. And so to understand Mars in that way, we have a lander and it needs to sit very, very still. And what you also can see is that there is a little, hang on, sorry, that didn't. Now we have it. So you see this little hood here, which is where that instrument sits. And the lander has sat it on the surface of Mars and put a hood on it to make sure the wind doesn't shake it. And we only record the shaking of Mars itself and the earthquakes of Mars. And if you want to see how this looks, that's a selfie. All instruments take selfies. And you see that hood is still sitting on the lander at this point. It was then put down onto the surface of Mars. You see the solar panels. That's how InSight gets its energy. And InSight also tried to put a probe into Mars to take the Martian temperature. Here you see some of the attempts. Unfortunately, Mars didn't read that script and the probe came back out. And so they have stopped that in order to have the region quiet and not have their own drilling and hammering all the time. And so InSight is now listening to Mars, figuring out what earthquakes are on Mars, and they found a few. But there is a spacecraft I am much closer to, and that's the Curiosity rover. Curiosity is currently the only active rover on Mars. And this is one of my favorite images of her, because you have Mount Sharp, the central mountain Gale crater behind, and you see this little gray smudge on front. It is just after a drilling. And if you think there is something that looks a little bit weird, and that is this, well, this is half of the arm, but you all know what happens. If I take my mobile phone and I take a selfie of me, well, what is not on that selfie is my hand that's holding the mobile phone. And here you go, the arm holds the camera that's taking the selfie, and that's why it's not in the picture. But you see the laser that's up here, you see its cameras, and you see some more cameras down here. So this is the Curiosity rover, and it has operated on Mars, and this is now the arm. We didn't see it in the last picture, and you see it sitting on the ground down here and doing a drill hole to sample. And we've done loads of drill holes, and this is how they are looking. So you have some of the drill holes which are red, as you would expect. The Duluth on the very right, for example, over here, this is a very red drill hole, as you would expect. But some of them are gray. And actually, our very first one up here, John Klein, is gray. Wow. And that is super exciting, because the red, and Amy said, the oxidizing red is from the cosmic irradiation, from the irradiation that comes to Mars, because it has such a thin atmosphere, and it oxidizes whatever is there. And if we are going to look for life, then that's bad news, because organic molecules, the ones that Mario talked about, they would get destroyed as the rock gets red. So finding gray rocks is really, really interesting, because that means we don't have to drill very deep to potentially find any traces if life ever had been on Mars. So I want to have one more beautiful picture, and that is Mount Sharp up here, and show you what we can learn just from pictures, because you see the different colors. It's a light beige up here, it's a brown here, you have almost black colors here, and you have another light beige tone here. You see the structures, lots of cracks here. These cracks tell us that they are clay minerals. Clay minerals form when water settles and is very still, and it has transported sediments. You all know this. If you go to some puddles in the summer and they dry out, you will see the cracks forming. And that's something that tells you there's clays. And that's no different on Mars, because Mars is a planet that's very, very much like Earth. But then you have these black things here. These are the sands that are still active and blowing around on Mars today as we speak. And there are some other things here that I just don't have time to get into, but you can ask me a question. So I want to end my talk with showing you this animation. If you look closely, you see that there is water and it goes away. So if you see the water in full, like now, this is 4.5 billion years ago. And then over about 100 million years, Mars dried out to the place that it is today, cold and dry. Thank you very much. That's me done.
Thank you so much, Suzanne. That was absolutely fascinating to learn how you're a geologist on another planet. It's just absolutely amazing that we can use all of these images we get from space without sending humans there. And we learn so much about actually what's going on with the geology, with the rocks, and we learn about the history of that planet. I find it absolutely fascinating. And the fact we've only got one active rover on Mars at the moment. There were many others that have been and gone, and they've all their batteries have run out, but actually only having one left is sad at the moment. So actually next week, fingers crossed, when Percy lands on Mars, we're going to have a friend on there as well. There'll be two of them. That was really great. If you've got any questions for Suzanne or Mario or Amy, then please send them in, and you can use the chat box, the Q&A function at the bottom. Now we're going to hear finally from James, and then we're going to enter into our Q&A. We've got tons of questions coming in, so I want to leave plenty of time for that. We've got one more question though for me to put to you at home or at school, just before we meet James. And my question is going to be, how long will it take for the signal from Perseverance to reach us on Earth. So next week, when the Perseverance rover hopefully successfully lands on the planet Mars, it's going to have to send a signal back to tell us it's got there. So we know that Mars is quite far away. So do you think it's going to be instant? As soon as that signal's sent, do you think we'll receive it on Earth? Do you think it's going to take 4 minutes to travel that distance from Mars to the Earth for us to receive it? 14 minutes or 40 minutes? Let's have a little think. We've got lots of answers coming in. Very popular at the moment is 40 minutes. I think almost all of you have finished putting your answers in, so I will share the results. So nearly half of you thought the signal is going to take 40 minutes to get to us, and just 6% of you thought it would be instant. So we will hear from James now. He's going to tell us all about future missions to Mars, and hopefully he can answer this question for us as well. Are you ready to go, James?
Yeah, I am. I'll just
Brilliant.
share my screen.
There we go.
Okay.
Yeah, that looks great.
Okay, thanks. So yeah, I'm going to do a very quick talk about the future missions going to Mars. But just before, I give a background of myself. So when I was at school, I was really interested in mathematics. It was my favourite subject. So I went to university to study mathematics. And after finishing that, I kind of took a year out trying to figure out what I wanted to do. So I actually worked at a pub for a while. And I picked up this book in the middle called Understand the Weather. And this book was written by a lecturer at the University of Reading, and it's all about how you can use mathematics and physics to understand the weather around us. And that really interested me. So I contacted the lecturer and he said, come and do a course with us. So I went and did that for a year. And when I finished that, this opportunity to study the weather on Mars came up. So I jumped at the chance. I went there and I haven't looked back since. And just in my spare time, just to show that I am a real person as well, I like to go on hikes with my family when it's allowed, obviously. I'm quite a keen snowboarder and a skier as well. I really enjoy it to relax. And I'm a very keen footballer as well. And I support Liverpool, so I hope that doesn't put anyone off from listening. And just a very quick overview of the research I do. So I run computer models. So this is what these globes are showing here of the Mars atmosphere and its surface. And I do this to try to interpret kind of the observations that come back from all the different satellites in orbit around Mars. So we have on the left here, this is the ExoMars Trace Gas Orbiter, which has been orbiting Mars now for around 4 years. And some of my colleagues in our team actually run one of the instruments on this satellite. So that's really cool to be involved in that. And on the right here, this is an older satellite, a NASA one called the Mars Reconnaissance Orbiter. But what I can also do is I can combine my computer models with the retrievals we get from the satellites, so of temperature, of water, of dust. And in that way, we can kind of constrain our simulations and eventually look to predict the weather that occurs on Mars, so that if any humans go there in the future, we can warn them on any kind of hazards that occur. And this is very similar to how we do it on Earth. And like the Met Office, when they release their forecasts, they'll have combined their computer models with all the satellites going around Earth and to get the best kind of guess of what's going to happen to the weather. Now, I'll go do a quick overview. There's a few too many missions to count for, but if you've seen the news this week, you'll have seen that there's been 2 satellites, one from the United Arab Emirates called Hope, and one from China called Tianwen-1, which have both just entered orbit around Mars and will soon be starting to take science measurements. So that's really good to have more satellites there to get more data so we can understand Mars more. I'm going to focus on the rovers here. So this is the Perseverance rover, which is going to, fingers crossed, land a week from today. But on the journey to get there, it needs to be shielded to make sure it actually makes it there in one piece. So this is kind of the setup, just a quick overview. It's got a shield to protect it. And this is a heat shield on the bottom. And this is actually the rover itself, so it kind of unfolds as it's released onto the surface of Mars. And this thing just above it is called a sky crane. You can kind of see it as a jetpack. And this is to land the rover safely on the surface because it weighs about the same as a Mini Cooper, and it's about the same size as well. So the conventional methods of using parachutes aren't going to work because it's a bit too heavy. So this is Perseverance on the right here. As you can see, it's very similar to the Curiosity rover that Suzanne showed in her slides. I'll just go over the new features for this new rover. So it also has an arm with a drill, but looking towards kind of returning samples from Mars, which is the next big step that we hope to take. This will actually store samples of the soil for hopefully future missions to come along and pick them up off the surface of Mars and take them back to Earth so that they can be studied by bigger instruments, which are more sensitive and they're not possible yet to take to Mars because they're so big. The other thing that's really interesting is this thing in the top right, and this is called the Ingenuity Helicopter. So this is actually stored under the belly of the rover while it's in transport and then gets released. And this is it's called a technology demonstration, which means there's no science on it, but they're just hoping to land it and perform some successful flights of it. And this is really exciting because what it means is that if it's successful in future missions, it can be used as kind of like a scout. So whereas this rover can only see in its kind of immediate vicinity, this scout can go and fly and have a look for kind of areas which are too hazardous to go to, or like places that look really interesting for the rover to go and take science measurements from. And yeah, as we've said, that a lot of the instruments here have to work autonomously, so they have to work without any human interaction. And that's because of the distance between Mars and Earth, and because signals can only be sent at the speed of light. It takes around 14 minutes on average, 14 minutes to get from the rover to Earth and back. So it needs to be able to operate by itself a lot. So because yeah, the signal won't reach it in time to avoid any hazards, for instance. And if you want to, there's more information at this website included at the bottom. It shows a really cool 3D model of this rover, and you can learn more about the instruments. And the other rover I want to talk to is the European Space Agency X-Mars 2022 mission, which was also mentioned previously. On the left here, this is it while it's being assembled, and it's actually assembled in the UK in Stevenage by Airbus. And I'll go over the instruments very briefly again. This, because it's a lot smaller and a lot lighter, this will be using the conventional kind of parachute method, so there's no need for this jetpack like there is for the Perseverance. And as it lands, it will initially be on this lander. It's called the Kazachok lander, which is developed by the Russian space agency, the Roscosmos. And this itself will have kind of its little weather station. It will take the local temperature and pressure. And this kind of ramp here is where the rover eventually come down onto the surface. And you have the mast here with the cameras that will take scientific measurements and have a look around. The solar panels, as I say, for power. But the really interesting new instrument is this drill on the front here, this black box. And what that will do is this can drill about 2 meters down to the surface. And I think so far the maximum is about 7 centimeters. So it's a lot further. And as Suzanne's mentioned in the past, the radiation on the surface means it's not very habitable for life now. But if there was to be life in the past, then it is very highly likely it'll be under the surface. So this is really going to be exciting to find the results from this. And any kind of samples taken from the drill will be injected back into the rover. And there's instruments inside the rover to perform analysis on the samples that are taken. And the only other thing I want to say is that a lot of people think that NASA are the only kind of space agency with astronauts, but the European Space Agency and Roscosmos are also, they have their own astronauts. And there's actually a call for the European Space Agency to apply for new astronauts, and that's coming out at the end of March. So if anyone's interested, yeah, keep an eye out for that. So yeah, this drill should hopefully find some really interesting results, and we'll find out about more in the future. So thank you. I can hand back over to Natalie.
That's great. Thank you so much, James. Yeah, I saw the call for astronauts was coming out, and I remember last time, I think I was too young to apply, and this time, sadly, I may be too old because I think there is a cut-off, but they may have changed the rules recently because I know that they're considering all people from, you know, any walks of life and everything. So maybe we don't have to be as amazing as we think astronauts have to be. They're looking at all different sorts of people. So you could be a scientist, an engineer, you might be a pilot, you could just be, you know, a doctor or something. They're looking for all sorts of people. So it'll be interesting to see who gets to be an astronaut in the next round of European applications. Okay, so that was fantastic. I feel like we've had such a great overview of everything about Mars, so the past and the future, and what's going to be happening. So let me see, should we start with some questions? I think what we need is all our scientists to come back on with their cameras and their audio on so that we can see everyone's lovely faces, and then I will be able to start asking my questions. So let's have a little look. Where should we start? We've had so many, and thank you all for joining in. I'm probably going to go over a few that maybe you've already answered in your talks, but I think we had a little problem with the YouTube link at the beginning for some people. So actually we may have missed Amy and Suzanne at the beginning, and Mario maybe. So let's have a look. One of the questions, who answered this one? How long does it take to reach Mars? Can we go over that again? Is that Amy or is that Suzanne? Who answered that one?
Yeah, so I think I've covered this a little bit. Yeah, so that distance to Mars, while it looks small and that Mars is our nearest neighbor, it actually takes a really, really long time to get there. So the Perseverance rover was actually launched back in July, and it's taken 6 months for it to get there.
Wow, okay, 6 months, that is a really long time. Can you imagine if we were sending humans to Mars? We're going to be talking about those same kind of time frames that it's going to take. So it's a huge journey for anyone to undertake. So actually sending robots and rovers is slightly easier because they don't get quite as bored when they're traveling through space. A great question. So another one which is really good to answer is, how big is Mars? Now that was one of the questions I posed to everybody, and actually we learned that it was about half the size of Earth. And I think Amy gave a really good explanation about that. Can you remember what you said, how many times around Earth it was?
Oh dear, everyone. It looks like we've got a little problem with Natalie's sound there. So I'm just going to step in and try and see if someone wanted to take the question, if they could hear what it was she was saying. I think Amy was about to talk, but I think Natalie's sound seemed to have gone a little bit for all of us. So if anyone wants to step in for the question, that'd be lovely.
I'm happy to give a good kind of analogy. So the surface area of Mars is almost equivalent to kind of the land area on Earth. So if you took away all the ocean on Earth and put all the land together, that's about the size of Mars.
Brilliant. Can everyone hear me now?
No, sorry, Natalie. I don't know whether unplugging it and plugging it back in might solve those problems. But whilst you try and sort of fix that for a second, I think we've got another question coming in. So let's ask. Oh, there's a good one here. So does Mars have earthquakes? It was mentioned earlier, I think, but if anyone wants to take that one.
Yes, it does. And they are not quite as strong as they are on Earth. So on Earth, we measure them in magnitude, and they are magnitude 3.5, the maximum that we have found on Mars yet. And that's a type of earthquake that you would sit in your living room and think, oh, what's this? Is this a big truck going past? Well, that's an earthquake about magnitude 3.5 if that happens here on Earth. It's not one of the big destructive ones that gets houses down and everything. And so we have found them. They are quite frequent, but they are usually just a little bit of shaking, and the maximum was 3.5.
I'm going to try again. How is my sound coming across? Woo, I'm not a robot any longer. That was funny because I think I was talking about sending robots to Mars, and then my audio goes like robotic. Okay, I'm glad I'm back because this is fun. I want to talk about life on Mars because we've had so many questions come in about, so there was one, could there be life in the soil on Mars? There was another one from Jensen. Are there any life forms on Mars? Diego, who's at 10, said, are there any creatures on Mars? Is there anything alive? I feel like this is a great question for Mario or Amy, who also probably knows quite a bit about this stuff. So if you want to take that between you.
I can start if you want, Amy, and then you can take it from there. Right, so far, we haven't found life on Mars at all. So what we're doing is trying to find it. However, because of the situation, the conditions that we have on Mars, we know that life is not going to be like the normal types of life we can find on Mars. If you think of normal environments, you normally have sunlight, and the plants are going to grow using the sunlight, and then they're going to feed herbivores, and then the herbivores are going to feed on carnivores. If you remember, James has mentioned that radiation on the surface of Mars is very strong. So that means that any kind of life surviving on the surface of Mars would just perish because they can't deal with it. However, we know that here on Earth, you can find microbes that can survive on the surface, and they're not going to rely on solar energy. Instead, what they can do is feeding on rocks. What they can do is oxidizing the minerals that you have inside of the rock to produce their energy. And also, if there is carbon around them, especially if you have carbon dioxide, this stuff in the water, what they can do is scavenge that carbon dioxide and generate their own organic matter, similar to what plants do using light, but instead it's going to be microbes using mineral oxidation under the surface. So that's what we're trying to find, if there is water under the surface, because if you remember, Amy's going to talk about it probably afterwards. for life, water is necessary. So we are trying to find where there is water on Mars, if there is, and then what the conditions on that water are, and then if microbes can actually survive on that water under the surface of Mars.
That's great. Amy, do you have anything to add?
Not really, no. I think maybe one of the really interesting things to think about, and a way to think about it, is if you were to stand on the surface of Mars, just how hostile that environment would be today. So we think about the really strong winds and just how cold we've said that the surface of Mars is, and compare that to how you feel sitting in your nice living room today and how it's warm, and you haven't got that crazy environment going on, and like that Mario has said, that we need to look under the surface, because the surface of Mars today doesn't look like it would be very hospitable.
So that leads me on to one of the other questions we've had. And I think from what you two have just said, I think we probably already know the answer to this one now. It says, would Mars be a suitable place to live? And I'm imagining they mean for humans, but also for other life. So what do we want to say to that? Could we ever live on Mars? Are we going to send humans to live there? Who wants to take that one? James, you look excited about that.
I'll take a little bit. So an extra bit about why humans wouldn't be so good on the surface of Mars at the moment is on Earth we have this ozone layer in your planet. So you might have heard about it over the Antarctic being a hole, but the ozone is very good at filtering out ultraviolet radiation, which is what reaches the surface on Mars. So if us as a human stood on Mars right at the moment, what we get very, very badly sunburnt. So where on Earth we're protected a lot of the time from this ultraviolet radiation, on Mars you don't get that. So on Mars, the options for kind of humans eventually living there is either to kind of terraform the whole planet, which is a massive undertaking, or to live in habitats kind of that are protected. So you need a protected layer on kind of your habitat that could filter out all this harmful radiation, which otherwise would affect us. Yeah.
Okay, that's really good. So it's going to be a little while before we can all move to Mars. I'm not sure I want to, because I really quite like Earth, actually. I think it's a nice place most of the time when we're not in a pandemic, perhaps. Maybe a question for Suzanne here. We've got from Annabelle at Europa School. Europa, that's brilliant. That's a very space thing. So there's a moon in the solar system called Europa. So I think I'd like to go to that school. How are the probes made to cope with the environment on Mars? So we've been talking all about how it's very hostile to life, but how do we make robots cope with that?
Well, that's a very good question, because when you go out today and think it's chilly cold with our -5 degrees Celsius that we have this morning, on Mars it's 10 times that cold. And while your mobile phone or any other electronic, and when I come back to your mobile phone, it's the same kind of principle that a rover would work on, the rover's memory and everything. So your mobile phone would be fine out at -5. It would not be fine at -50. So what the rover needs is it needs to heat. And I showed you the solar panels on the inside lander. And so it takes most of its energy that it takes from these solar panels just to keep itself warm, just to heat itself. And so that's the first line of defense. And when Natalie in the very beginning said, when the rover battery dies, then the rover dies, or any spacecraft battery, and that's mainly because everything freezes. And when everything freezes, that's the end. And so the energy that's generated is, first of all, life support, warm the interior. And the second is you need to build the outside so it can withstand the sandblasting. But then you've got cameras with lenses. For example, on the rover arm of the Curiosity, there is the Mali instrument, the hand lens imager, and that's very sensitive. So there is a cover. And when we know that if we don't need the instrument, we close the cover. And if there is a lot of dust in the atmosphere, that cover remains closed and the instrument just doesn't operate, because when we get it sandblasted and scratched, it would be useless for the rest of the mission. So there is technology to protect and just put a cover on, as you would do with your camera here on Earth, and keep warm. That's the most important things. And the other thing is we don't operate when it's really cold at night. during daytime, it gets a bit warmer when the sun is out and hits the surface. So then we get to -5, maybe even some +5 degrees C. And then we drive. We wouldn't ever drive at -50 degrees C because the steel and all the materials of the rover, they are actually getting quite brittle at that temperature, and we could damage it much easier than during daytime. So it's a lot of things that we have to take care. It's a bit complicated, but that's why we have the engineers.
That's a really great detailed answer. Thank you so much. Thinking about heat on Mars, there's actually a really good question for Amy, and it's are there volcanoes on Mars? Now, I know you mentioned that there's definitely one that was called Olympus Mons, and it's absolutely enormous. Is that the only volcano on Mars?
So I think the main thing to mention about volcanic activity, and it's not my area of expertise, is that Mars was much more geologically active in its past. So most of the volcanoes that we see on Mars actually no longer are active. So they're no longer erupting or producing any kind of lava or ash. But in the past, there would have been quite a lot of volcanic activity across the surface. So along with Olympus Mons, along that equatorial region in the middle of Mars, there are other quite large volcanoes as well.
Yeah, brilliant. And actually, I loved that, you likened Olympus Mons to, bigger than Mount Everest, but actually it doesn't look it, does it? And that's the funny thing about these volcanoes. They're very flat. So actually they're just very wide, because in order to be that high, and not look very high, they've got to be very, very wide. So that we have similar volcanoes on Earth, don't we? They're called shield volcanoes. They're meant to look like the shield of a warrior's shield lying on the floor. And so, yeah, that's their kind of shape, but it doesn't mean that they haven't been producing tons and tons of lava in the past. Now, I've got a great question from Mario, and it is, how do you find your analogues? How do you go about finding these analog environments on Earth?
That is a brilliant question. That is a brilliant question. And actually, it depends a lot on what you want to do and what kind of research you want to conduct there. So for example, if you, in my case, if you want to do a microbiological kind of research, your main interest is that chemically, your environment needs to be similar to what we know about Mars. So for example, the Basque Lakes in Canada, we know that they are very sulfate rich. And we know that there is sulfates on Mars, and when Mars was drying, sulfates become more and more common, and this is what we use. But for example, you can also want to use analogues for rovers, and I'm so sure Sana can talk about this more than me, but if you want to actually check how a rover would work on Mars, you actually need to have a similar kind of terrain to the one you would find of Mars. So you can actually put your rover there and see what kind of things they are going to struggle with, or how to improve some processes. But also, you can also have analogues for human exploration. So imagine that you want to send in the future humans to Mars. So one of the things that you need to do is simulating the kind of situation of societal, of the kind of interaction between humans you're going to have on Mars. So you need to send them to a very isolated place that's going to have quite extreme conditions. So they're going to be isolated in these mini bases, and they're going to go out of the base. They're going to do their research around. They're going to try to feel how it would feel on Mars. And some of these human-like analogues are on deserts, because they are far removed from society. They're going to have struggles to try to get interactions from outside. So I would say that the best way to choose an analog is thinking, what do you need it for? And what are the requirements you need for that?
Okay, thank you. Now I see we have only about 5 minutes left. So what I want now is some really quick fire answers, even if the questions don't seem like you can make your answers really short, but I'd like to get through as many questions as we can, so we've got so many coming in. One of them is from Shelby at Kents Hill Park School, and they have asked, why are we so interested in Mars when we've got so much of Earth to explore still? Who wants to take that one? Go on, James.
So Mars is, one, it's the closest planet to Earth, so it's easiest to get to, and two, it's the most Earth-like planet, really. It's as in kind of the atmosphere. It has an atmosphere. It's not too hot. It's not a gas giant. It's got a solid surface. So it's kind of, we don't have anything to compare to the Earth. So we see processes in our Earth's atmosphere, and we have nothing to compare it to. So Mars is definitely the best option. Yeah.
Brilliant, thank you. That was nice and short. Suzanne, I'm going to give you a challenge now. What happened to Mars's magnetic field and its atmosphere?
Well, Mars, a magnetic field goes away as a planet cools. So in many, many, many million years from now, the Earth will also go away. And Mars is much smaller, as we heard from Amy in the beginning. So it has cooled, and the core is now not liquid anymore. And so there is no magnetic field. The atmosphere is much harder to answer because it should be there. We know that some of it got lost to space. We know that some of it got lost suddenly, which might be because Mars got hit by another meteorite or something. But that's something we are currently figuring out. We know that it was thicker, but exactly how it got lost, we only have hypotheses so far.
Excellent, thank you. Another one for James, because we're sort of looking at future missions here. A few people have been asking, why are there lots of different space agencies going to Mars at the same time right now? We've had 3 missions basically arriving within a week of each other. And do they have different objectives, or is there sort of space race going on? And are these teams all going to work together? Quite a long question.
Okay. So in terms of why they're all going at the same time, you only get very short windows where it's preferable to get to Mars. So if you launch at certain times, it will take like double as long to get there. So the reason why they're all clumped together is because this was like the perfect time to get there in the shortest like time frame. And in terms of collaborating together, so the UAE mission actually was heavily involved with NASA because the UAE didn't have any space expertise in the past. So a lot of the instruments on that spaceship are from America, so there'll be a lot of collaboration between them. I don't know as much about China, to be honest, and I can't remember what the other question you asked.
The final bit was, are all these teams going to work together? What's the kind of the collaboration like across the world? We've got different people sending missions.
Yes, it's quite good. So I work in an international team with a lot of Europeans, so Belgian, Spanish, Italian, French, and I also have collaborated in the past with NASA. And a lot of the, as I say, the instrument teams for the UAE mission are from America. So it'll be highly likely that we'll be able to kind of collaborate. And so a lot of it, everyone kind of wants to improve our understanding of Mars.
Brilliant. In the long run. Thank you. That's great. Mario, a quick one for you if possible. What types of microbes are you expecting to find on Mars? What are you looking for when you're going there?
Right. The kind of microbes I expect to find are microbes that can feed on rocks. Microbes that actually can produce gases like methane, because we know that in kind of similar situation, they can also survive. Those are the kind of microbes I try to find. And I think that we could, hypothetically, if we would find them, those are the ones that we would find.
Okay, that's brilliant. Can we ask, maybe this one could go to Amy. Somebody's asking, do plants grow on Mars, or can we even grow plants on Mars in the future? Oh, you're muted, I think. There we go.
Yeah. So yeah, that's a question that I've actually been thinking about a little bit lately, in that in my work, I'm actually designing a soil simulant for Mars. But one thing you could possibly try to do with that is to see, well, how difficult would it be to grow plants in that kind of soil? So the question is, does the soil produce the kind of nutrients that plants would need? Obviously, then, if you were going to grow plants on Mars, you couldn't just grow them outside. I think James has talked about that people would need to be in some kind of shielded environment. And that's the same then for plants. You would need your plants to be shielded from the outside and to have an oxygen-rich atmosphere created inside some kind of tent.
Okay, that's brilliant. There's a final question I think we've got time for, and it's from Misty. She says, realistically, when can we expect the Mars samples to be brought back to Earth? So have we got any sample return missions planned? I think that might be Suzanne or James. They're kind of the people I might think answer this one.
I can take this. James has said the Perseverance rover is going to collect samples in sample tubes. And we are thinking that in 2026, there might be a NASA and ESA collaboration. So Europe and America, here we are about working together, sending a fetch rover. And what's especially interesting for me that Fetch Rover will sample pick up the sample tubes, and it will suck in the Martian atmosphere and bring all of this back to Earth a couple of years later. That's the current plan.
That is fantastic. I can't wait for that. I bet you're all going to be very excited for that to happen. Oh my goodness, we have flown through some questions, but we have run out of time. I can't believe it. That's gone so quickly. We haven't been able to answer all your questions today, and I'm really sorry that we couldn't get through them all, but we had literally over 100 questions coming in. So if you'd like to resend us your question, if you want to email it to us, then you can do that, and we will try our best to answer some of you, or perhaps we will put something on our webpage answering some of the common questions that you've asked. Just email that to STEM, that's STEM -communications@open.ac.uk. And yeah, we'll do our best. So check our Twitter pages, or we might send out an email digest to the schools. We'll try and figure out how to answer all those questions we didn't get through. Now, we've also compiled a whole bunch of activities you might want to check out after this event. There's colouring pages for the little ones, or online space games, and there's also detailed web pages that will answer maybe some of the questions that you still had that we didn't get time for. You could even have a go at building your own Mars rover. I think the team are going to put that in the chat so that everybody can see that and click the link. We also have a lovely little survey that you might want to help us out with. Now, we're getting kind of new to running these kind of events online, because we're used to meeting people in person, which is kind of much nicer because we can see all of you. But for now, we're doing things online. So we want to see how we're doing and if there's anything we can do differently, and who you are, who's come along to meet us today, because we can't see you. So if you have time to fill out the survey, that's in the chat box as well, and that would really help us out for any future events. But I'm afraid that's all we have time for today. But thank you so much for joining us, and we all wish every success to NASA for